Okay, so we totally switch gears when we get into Unit 3. We're now going to be working with radicals. Square roots, cube roots, fourth roots, and you have to have a calculator for this section. You can't use a cell phone, you can't use an iPod, it has to be a dedicated scientific calculator. Now, someone took it, obviously, because I had a few to borrow. One of the calculators that I handed out, I think, Kevin, you got it. That's from the Dollar Tree, and that will do everything you need for this class. So you don't need to invest a lot of money. That little calculator there, I only know that they have them because a student last year got it there. And sure enough, it'll do square roots, cube roots, fourth roots. It'll do them all in that little calculator for $1, $1.06 with tax. So you don't need to spend a lot of money. You do need a calculator. There are problems in this section you literally cannot do without a calculator. So first thing we're going to talk about is a little bit of language. So this is what our radical looks like. The radical is kind of like that extended division sign with a little tail on it. The little number that we put in the crook is called our index number. You're going to hear me referring to index a lot. Index. And then the value underneath is our radicand. So that's going to be some of our new language for Unit 3. We're looking at radicals. We're going to be concerned with their index and their radicand. So what made Unit 2 hard was all of the problems had a lot of steps. Everything was just really long. Unit 3, the problems are typically pretty short, but for a lot of you, the rules for working with radicals are going to be new, and that's what makes it difficult, is that there's just a lot of little rules instead of those big, long problems. So that's the difference kind of between Unit 2 and Unit 3. So some definitions. A square root is a number that produces a specified quantity when squared, multiplied by itself. A cube root, a number that produces a specified quantity when cubed, multiplied by itself 3 times. Fourth root, same thing 4 times. Fifth root, keeps going and going and going. So you've probably seen square roots before. So what's the square root of 25? 5. And it's 5 because 5 times 5 gives you 25. So the square root of 25 is 5. Now, that's only half of it. There's another answer to that problem. Your calculator is only going to give you the answer 5. But there's another number that when multiplied by itself gives me 25. Negative 5. Right? Negative 5 times negative 5? Still positive 25. So there's actually 2 answers to that. Positive 5 and negative 5. Both of them are answers to the square root of 25. Now, I'm not always going to be asking for 2 answers. We have what's called the principal root. That's the one that you thought of right away. You thought of the 5. It's the positive answer. It's the one your calculator gives you. But there's also a negative square root. Now, if I want the answer to be negative, all I'm going to do is write the problem as negative square root of 25. That's how I tell you, instead of the positive answer, give me the negative answer. You just put a negative sign out front. So it's the difference between asking for the square root of 25. I'm always looking for the principal root there versus negative square root of 25. That's how I get the negative root. But there are 2 answers, which we're going to need that idea later when we solve some equations using square roots. There's always a principal and a negative root really behind it. So what we're going to talk about now is this table of numbers, which is going to be your best friend for all of Unit 3. And this is our table of perfects. Perfect squares, perfect cubes, and perfect fourths. So if you were sitting at home and you had to make this table yourself, because again, it's going to be your absolute best friend for this unit, to find your list of perfect squares, you just take your column n, which is kind of like your base column, and you square every number in that first column. So 2 squared gives me the 4, 3 squared gives me the 9, 4 squared gives me 16. So next would be 5 squared is 25, 6 squared is 36. So you'd have a calculator, assuming you brought a calculator, And so you could quickly square all of your integers to fill in this table. So for 8, we'd get 8 squared, whoops, is 64. 9 squared is 81. 12 squared is 144. So you could pretty quickly make this table because, again, it will be, and you'll see when we get to 10.2y, your best friend in Unit 3. For perfect cubes, these are all the numbers, the perfect cubes that I could take the cube root of and get an even answer. So this is every one of my numbers from that first column, n raised to the third power. So 2 to the third power is 8. Next would be 3 to the third power, which is 27. 4 to the third power, 64. And if you don't know how to raise numbers to powers on your calculator, I'd be happy to show you that. 5 to the third power, 125. 6 to the third power, 7 to the third power. A bunch of those are already filled out for you. 10 to the third power is 1,000. You get the idea there. And then perfect fourths, these are all the numbers you could evenly take. You get a nice integer answer, your fourth roots. So now we're at 2 to the fourth, 3 to the fourth, 4 to the fourth, and so on down that list. So any questions on how to make that table? If you had to make that table for yourself, would you be able to? Just write numbers 1 through whatever, 1 through 12, raise them to the second power, raise them to the third power. We don't actually work with fourths a whole lot, but we will see occasional fourth roots. Okay. So 10.1 is what I like to call our bubblegum world. So in 10.1, everything is perfect. Every time we have a number, it's in this table. Every time we have a variable, we'll see what makes variables perfect in terms of our radicals. Everything's perfect. Then we get to 10.2 and everything's not perfect, and that's where you really, really, really need this table. So let's look at some of our problems here. So I've got a little good to remember. If the index, so the index is that little number inside the crook. If the index of a radical is even, a negative number underneath the radical is not a real number. So sometimes our answers for now might be not a real number. When we get to 10.7 later in Unit 3, we're going to learn about imaginary numbers and complex numbers, and then it doesn't matter. If the index number of a radical is odd, a negative underneath the radical can be evaluated. So we're going to be looking at that little number to tell whether or not we have a real number. So simplifying perfect radicals, identify the root of any number. For the variables, divide the exponent by the index. And for fractions, we're going to separate them. So I'm going to teach you today how to use your calculator to find all of your different roots. You could also use your little perfect table on the front. So square root of 36. 6. Now how to get that with your calculator. So I'm going to go through 3 different types. I'll do graphing calculators. How many, do we have graphing calculators? Okay. Then we'll go through scientific calculators that hold a display and scientific calculators that don't hold a display. So if you have a graphing calculator, you know what, let me make a separate. Okay, so for square roots, if you have a graphing calculator, you want to hit the math button all the way on the left side. Sorry, we're not, that's next. I'm doing cube roots, sorry. You just need to hit second and then x squared. Oops. You're going to hit second and then your x squared, and you'll see this appear on your screen. It'll be a square root with an open parenthesis. Then type in your value, so 36, and then it's always a good habit to close your parenthesis and hit enter. So second x squared, so you see your square root, type in your number, close the parenthesis, hit enter. If you have a TI 30x2s. So that looks like, and these come in a lot of colors, looks like that, something like that. It's actually the same directions. You hit second, your x squared will get you your square root up. I hit second first. So it's going to be the same directions. Second, x squared, it'll have a square root with an open. Type in your number, close your parentheses, and hit enter, which is also the equal sign. Now if you have, actually I have a dead one of these. If you have something that looks like this, or most of your others that don't hold the display, yours holds a display, so yours is going to be a little bit different. So this is like the one that Kevin has, or any of them that don't hold a display. On these calculators, you actually have to enter the number first. So if you have a calculator that doesn't keep a big line of what you've entered, you're actually going to enter the 36 first. And then on these guys, which is the most common one, you actually just have a button that looks like this. If you type in 36 and then the button that has the square root with the x, it gives you the answer. Is anyone not able to get the square roots with their calculators? Yeah. Yep. Yep. Anyone else? Okay. So using your calculators now, find the square root of 0.36. And the square root of 0.36. What do we got? 0.6. Is everyone able to get that? A big part of today is just being able to find these perfect squares in your calculator. So that one's 0.6. So that seems pretty easy, and then hit a wall. Now we're to variables, which is probably a topic you haven't discussed before. Now, variables are not hard when they're perfect. The rule is to divide your exponent by your index number. Well, we said the index on our square roots are the little numbers right here, but there's not a little number written right there. There's not a little number explicitly written. In some of our problems there is, like down here there's a little 3. Somewhere further we've got a little 4 for an index, but there's no index written on a square root. Reason being, it's our most common radical. Math people are lazy. The less we have to write, the less we will write. So it's one of those where it's implied. Just like when you write x, we know there's a 1 out front. When you have a square root, your implied index is 2. Because think, every answer comes from something squared to the second power. So that's why it's a little 2 right there. Cube roots have a little 3 because it's something to the third power. That index is all related to what power we're looking at. So for variables, all you're going to do is take the exponent and divide it by the index. So the index for my problem is 2, so I'm just going to take the 6 and divide it by 2, so I get x to the third power. So for variables, you take the exponent that was already on my x, and I divide it by my index. Anna? Yes, you always keep the variable. Yep, the only thing that's changing is the exponent. Let's think about it. So think about your definition of a square root. So we said 25, the square root of 25 is 5 because 5 times 5 is 25. What's x to the third times x to the third? What do you do when you multiply? What do you do with the exponents? Add them. X to the 6. So that's why it works. It's just because x to the third times x to the third is x to the 6. How about D, negative square root of 49? Negative 7. So if I want the negative root instead of the principal root, I just throw the extra negative sign out front, carry it out front. Negative 7. And then we get into cube roots. So let's go back to the calculator list. Yeah. So if we're looking at a cube root now, for our graphing calculator people, this is where I was jumping the gun a little bit. If you have a graphing calculator, you're going to hit the math button on the left side, and you actually have an option for a cube root. If you then just type number 4. You can scroll and hit enter, but it's just quicker to hit number 4, and then you'll see the cube roots opened on your screen. Enter your number, which is 125, close, and then hit enter. If you have this guy, the one that holds the display, you actually have to enter your index first. So you have to enter the index first for anything above a square root. So our index on a cube root is 3. So the first thing you're actually going to do is type a 3. Next, it's second. And the key that looks like a little roof of a house, your caret key. And what you should see now on your screen is 3 and then a radical that has a little x with it. And what your calculator is doing is it's sucking that big 3 in place of the little x to be a cube root. You're going to type 125. It did not open parentheses, so you don't add any to it, and then you just hit your enter equal. For anyone's calculator that doesn't hold a display, I'm going to have to remember how to do this one. You're going to enter your 125 first again. You're going to hit second, and somewhere on there you should find a button, it's usually a second, that looks like that. And after you type that, you're going to have to enter the index. They're all backwards. 3, and then hit whatever your equal sign is. Everybody able to get a cube root on their calculator? So what's the cube root of 125? 5. So when we have numbers and variables, we're just going to go down the list and look at each piece of that individually. So we started with the number. The cube root of 125 is 5. How about the cube root of x to the 15th? X to the 5th. So you take the x to the 15th and you just divide your 15 by that index number, which is written out for us here to be a 3. You keep that variable, so it's x to the 5th. And then for y's, we take our y, take its exponent, and just divide it by the index. So we have y squared. So numbers you can get from your calculator or from that table on the front. Variables, you just divide your exponent by your index. So how about the cube root of negative 343? The cube root of negative 343. Negative 7. So if you put that in your calculator, it gives you back a value. It's okay to have negatives underneath that radical as long as the index is odd. So with cube roots, it's okay to have negatives underneath, because if I multiply negative 7 by negative 7, it turns positive. Multiply it by another negative 7, it gets back to negative. So that's okay. How about the cube root of x to the 3rd? X. So you just take the 3 and divide it by my index of 3, which gives me x to the 1st, or just x. Try the square root of negative 25 in your calculator now. Square root of negative 25. And what happens? You get an error message. Doesn't work. What's my index on a square root? 2. If your index is even, and there's a negative underneath the radical, it's not a real number. And that's what we're going to write for now. Once we get to 10, 7, and we know how to write imaginary numbers, we can write that a different way. But for now, we're just going to write it's not a real number. If you can't remember whether or not it works, just try it in your calculator. If you get an error, you know it's not a real number. But when you tried F here, it worked. So a negative underneath doesn't automatically make it not real. It's only if it's a negative underneath and the index is even. Now, H and I are just to illustrate a point that we're actually going to use a little bit later. When you have an operation underneath a square root, you need to take care of that first. So in this problem, I need to add together the 144 and the 25 first, since they're underneath one square root. So I'm looking at the square root of 169, which I can use a calculator to evaluate. It's 13. No, once you evaluate it, it's out, which is a lot of people are going to try to do that. So once you evaluate the square root, your calculator gives you the number 13. There's no more square root around it. It's just the number 13. It just says 13 times 13 gives me the 169. Now, do you think we're going to get the same answer or different answer for I? Different. It makes a difference whether or not we evaluate them under 1 or split them up if we're looking at addition. So for I, the square root of 144, 12 plus the square root of 25 is 5, and 12 plus 5 gives me an answer of 17. So we can never break up square roots through addition. The only way we're going to be able to break them up are multiplication and division, which we'll do starting in actually 10.3. I mean, not 10.2, 10.3. Now, J is our fourth root. So this is our first fourth root. This is where nobody on your calculator has a fourth root button. Nobody. Even graphing calculator people lose them. But if you have either of the scientific calculators, it's exactly the same, except you just enter your index as 4 instead of 3. So those directions are exactly the same. It's you graphing calculator people that have lost Easy Street. So for everybody who holds a display again, you're going to start by entering your index. So we're looking at a fourth root now. So your index on a fourth root is 4. So both these people are going to start by entering a 4. If you have a graphing calculator, you're then going to hit Math and Choice 5. So your screen now looks like big 4, X root. And what your calculator is doing again is taking that 4 into the index. If you have the scientific calculators, it's second caret key again. And again, you'll look the same. Then you can enter your radicand, which we're at 625. There were no parentheses, so don't add any in at this point and hit your enters or your equal. And if you have this type of scientific calculator, it's the same process. You're going to enter your radicand first. 625. Usually it requires a second function. You're looking for that, and then enter your index. It's just opposite, and hit enter or equals. So what's the fourth root of 625? 5. Go back here. And how about the fourth root of x to the 16th? X to the 4th. So you just take that 16 divided by your index of 4. You get x to the 4th. Now, people tend to not like fractions, but when you're working with radicals, all you have to do is look at the numerator and denominator separately. So when you see a fraction, it's underneath one big radical. We'll actually learn a little bit more about this later. You just have to evaluate the numerator and denominator separately. So the square root of 9 is 3, and the square root of 25 is 5. So the square root of that fraction is 3/5. You just look at the numerator and denominator separately. Keep it as a fraction. Because they're not always going to work out so nice. And then the same thing for L. You've got the negative sign out front, so you're just going to have a negative sign in front. Then I'm looking at the cube root of y to the 6th over the cube root of 8. I'm just going to break it up since it's a fraction. We can evaluate the numerator and denominator separately. Again, negative sign out front. What's the cube root of y to the 6th? Y squared. Just take 6 and divide it by 3. And the cube root of 8 you can either get from the table or from your calculator, or if you know it, 2. And it just stays as a fraction. Kevin. There's only one negative. So when there's a negative out front, it goes to either the numerator or denominator, but it doesn't go to both. Or the way books write it is right out front, but there's only one there. It's for either or. Good question. Same question? Great. So any questions on our basics of evaluate? So there's two other topics, little topics in 10.1. The first is using our function notation to find some values. So using our function notation. So f of x equals the square root of x plus 5. We want to find f of 4. What do I do with the 4 there? Sarah? Yeah, just put in for x. So this is what we did back in chapter 8. So if we want f of 4, all we do is replace the x with 4 and evaluate it. So this is going to be the square root of 9, which is 3. So it's function notation just like from chapter 8. Replace the x with your number and evaluate. This question's also looking for f of negative 8, so we're going to do the same thing again. So we're looking at the square root of negative 8 plus 5, which is the square root of negative 3. And the directions do say, if necessary, round to 2 decimal places. This is about the only time you'll ever approximate square roots. But what happens if you try to type in the square root of negative 3? You get the error. So what does the error mean? What do we know about this number? Not a real number. And if you forget, if you look in your directions, if the value is not a real number, so state. So this particular one, your answer is just not a real number. Because my index is even. Index is odd, do what you want. Doesn't matter. Index is even. For real answers, we have to have a positive radicand. So B, we have g of x equals negative square root of 3x minus 2. We want g of 3. So we're going to replace that x again with a 3. So 3 times 3 minus 2 going to be the square root of 9 minus 2, negative square root of 7. Is that going to be a real number or not a real number? It's a real number. It's not perfect, but this particular set of directions said you could get decimal approximations. When the negative sign's out front, it just means your answer is going to have a negative sign in front of it. So negative sign out front is always okay. And then it wants you rounding to 2 decimal places. So in your calculator, you're going to get your square root of 7. It's 2.6457. So my rounding to the second place, look to the right. 5 tells me to bump it up. So we're looking at negative, should probably do approximately equal to, negative 2.65. So you want to round to 2 decimal places, so you go to the second place to the right. Look to the right of that, you see a 5, which tells you to increase the 4. Sarah? No, if your index is odd, so like when we had a cube root, the negative inside's okay. The times you can't have it is if you have a square root, because your index is 2. If you had a 4th root, your index is 4. Can't have a negative underneath. If you had a 6th root for some reason, couldn't have a negative underneath. So it's this right here. If the index is even, no negatives underneath. If it's odd, it's okay. And if you can't remember, just try it in your calculator. If your calculator gives you the error, you know it's not real. If it works, then you know you're all set. All right, last topic for 10.1, domain. So we talked about this topic. This is actually a little bit related to our Unit 2 start of it. When we have a fraction, what's our trouble area? When we had a fraction, what's the trouble area that leads to our domain? The denominator can't be 0. We're asked for domain again, but this time we have a square root. When did we have a trouble? When were you getting an error with your calculators when we were working with the square roots just now? When there was a negative underneath. When we had a negative under a square root, you got an error. So what's true of our radicands is the radicand has to be greater than or equal to 0. If it's not, then we don't have a real number. So when we're looking at the domain, we want to make sure whatever's underneath our square root is 0 or positive. Because if we have a negative, it doesn't work. So for your domain, what you're going to do is you're going to take your radicand and say it's got to be greater than or equal to 0. Because if it's not 0 or above, it's not a real number. And now we want to solve that. So to solve it, we're going to subtract 2 from both sides. So we see x is greater than or equal to negative 2. Now our directions, just like before, ask us to write using interval notation. So let's think about it on the number line again. We're starting at negative 2. Which side of the number line is greater than negative 2, the right side or the left side? The right side. These are all the numbers that are bigger than negative 2. How do I show it's equal to negative 2 when I start? What's our notation to show it starts at negative 2, including negative 2? Square bracket. So remember sometimes we had the parentheses, sometimes we had the square bracket. We're including negative 2 because we said greater than or equal to square bracket. And where's that interval going? Positive infinity. Square bracket or parenthesis around positive infinity? Parentheses. Always parentheses with infinity. We might skip match it to its graph. Well, which of these graphs starts at negative 2 and then shows all numbers bigger than negative 2? I just really need to label these someday. B. So this is really the question I'm going to be asking you. Your homework gives you a graph to match it to. It's graph B. So the same thing for our next example for g of x. When you're asked for domain of a square root, you're always concerned with the radicand, and your trouble area is that it has to be greater than or equal to 0, or it's not a real number. So when you solve inequalities, this is an 82 topic, you really want the x's on the left, is how we're used to reading them. So I'd subtract the 8, so I'd have negative 2x is greater than or equal to negative 8. And what's my last step to solve for x? Divide by negative 2. Who's on top of it Monday morning? What happens to an inequality when I divide by a negative? Shakira? You flip it. So x is less than or equal to 4. So if we want to set up our interval, which side of my number line shows values less than 4? Yeah, the left side. So where does that interval start? Negative infinity. Since it's the left side, it actually starts all the way back at negative infinity. I use a parenthesis. And then it goes up to 4. Parenthesis or brackets? Bracket. Because we have that equal to. And then if you're doing your homework, again, I'm not going to give you the graphs on like a test or anything, but on your homework, which graph shows numbers up to 4? Okay. So it's numbers 4